the aging transportation infrastructure in the Northeast, the structural integrity of hundreds of concrete bridges has been badly compromised and need immediate repair. CarbonWRAP Solutions of Tucson, Arizona provides innovative products and turnkey engineering solutions as an effective and economical alternative for the repair and retrofit of bridges using fiber-reinforced polymers. CarbonWRAP's fiber-reinforced polymers come in the form of woven or stitched fabric that is saturated on premise and bonded to a substrate using a specially formulated structural epoxy. The fiber resin composite also comes in the form of pre-cured laminates for application to surfaces that are smooth and can handle the relatively rigid cured laminate. These polymers, with correct application, increase the ductility and strength of concrete structures, making them last longer at a fraction of the time and cost of using conventional materials and techniques. The Department of Transportation in both Rhode Island and Massachusetts had recently contracted with CarbonWRAP to provide solutions to 3 different types of concrete bridge structures that needed immediate repair. The first bridge had severely eroded concrete beams. The second bridge was a double-arched concrete span that needed complete reinforcement. And the third bridge needed repair and strengthening of cylindrical concrete columns and horizontal beams. Project 1, Goat Island Bridge, Newport, Rhode Island, concrete beam repair. This project included the repair and strengthening of pre-stressed eye girders at the 4 end-span structures over the Newport Harbor. The bridge needed emergency repairs due to severe erosion of the concrete beams on the underside of the bridge. This erosion was caused by direct contact with salt water due to the extreme nature of the tides in the Newport Harbor. CarbonWRAP determined that the solution for this project was to increase both the flexural and shear strength of the badly eroded concrete beams. For flexural strengthening, the company determined that the underside of the beams would be bonded with pre-cured rigid fiber resin laminate strips, and the entire beam would then be wrapped with the CarbonWRAP flexible fabric. Upon completion of the bridge restoration, a proof load test was performed on each span that was repaired. The test was digitally measured and the bridge capacity exceeded its original 19-ton limit. Project 2, Hopkinton Westerly, Rhode Island, double arch span type bridge. Situated in a rural part of Rhode Island and crossing a 75-foot wide river, the structural integrity of this historic double arch bridge was compromised by old age and by the recent massive flooding in 2010. The entire bridge needed complete strengthening, and CarbonWRAP determined that they would wrap long laminate strips placed approximately 18 inches apart along the length of the underside of the span. They would then use the CarbonWRAP flexible fabric to wrap across the width of the underside of the bridge and up around the sides of the structure. The entire structure was then painted and tested by the Rhode Island Department of Transportation. Project 3, Hopkinton, Massachusetts, Highway 495 and 90. This bridge is at a major highway intersection about 25 miles from Boston. The bridge was in need of repair of both concrete columns and concrete beams that had been eroded due to age, weather, and heavy use. For this project, it was determined that the columns and beams needed significant removal of the eroded concrete, necessitating a variety of types of forms to rebuild both the vertical columns and the horizontal beams. Once the concrete was rebuilt with the CarbonWRAP concrete substrate, the plan was to wrap the concrete columns with the flexible fabric from the top to the bottom of the columns. The horizontal beams would then be wrapped, first with the laminate strips, and then the beams would be wrapped with the flexible fabric. CarbonWRAP has proven solutions for almost any kind of concrete structure that is in need of repair and looks forward to helping rebuild America's transportation infrastructure.